thiophene. And this and this is really the sulfur analog to the pyrrole molecule that we studied. So let's start by analyzing this sulfur in terms of its steric number, right? So I'm going to look at this sulfur right here. We're going to calculate the steric number of that sulfur. So number of sigma bonds to that atom. So here's a sigma bond, and here's a sigma bond. So we have steric number is equal to number of sigma bonds plus number of lone pairs of electrons. So we have 2 lone pairs of electrons around that sulfur like that. So that would be 2 plus 2, which is equal to 4, which implies that sulfur is sp3 hybridized. But that doesn't work for our concept of aromaticity, because in order for something to be aromatic, our atom needs to be sp2 hybridized, so it has a free p orbital, just like these carbons right here. So once again, these carbons all have a double bond to them, so those carbons all have a p orbital, so I can go ahead and sketch in those p orbitals on those carbons like that. So the sulfur looks like it's sp3 hybridized, but of course it's going to be a similar example to the pyrrole molecule. I can show a resonance structure for this thiophene molecule. I can take one of these lone pairs of electrons, I'm going to say it's the lone pair on the right here, and I could show them moving in to form a pi bond between the sulfur and this carbon, which would of course kick these electrons off onto that carbon. And so when I go ahead and draw this resonance structure, right, so now there's a pi bond between the sulfur and this carbon. Lone pair of electrons moved out onto this carbon, giving that carbon a -1 formal charge. There was still a lone pair of still a pi bond, I should say, over here, and there was still a lone pair of electrons left on this sulfur. So now we can also give this sulfur a +1 formal charge, and we can analyze it in terms of its steric number. So once again, number of sigma bonds. So this is a sigma bond, this is a sigma bond, and so the steric number would be equal to 2 plus how many lone pairs of electrons? Now there's only 1, so 2 plus 1 is equal to 3. So now we can see that it's actually sp2 hybridized, so it has 3 sp2 hybrid orbitals, and one of those sp2 hybrid orbitals is going to contain that lone pair of electrons in blue there. So that lone pair of electrons, and again, it's sp2 hybridized, which means it has 2 other sp2 hybrid orbitals, and those hybrid orbitals are forming bonds with those carbons there. Since it's sp2 hybridized, it also has an unhybridized p orbital, so I can go ahead and draw in that unhybridized p orbital. And so I could think about one of those lone pairs of electrons on my original dot structure occupying a p orbital. So let's go back here and look at the thiophene original dot structure I drew. I could think about one of these lone pair of electrons, I'm going to mark it in magenta, as occupying a p orbital. So I can go ahead and put it in there like that. And I could think about the other lone pair of electrons on that dot structure as occupying an sp2 hybridized orbital out to the side. So whenever you see this sort of situation, think about where those lone pairs of electrons actually are. And so I also have these as being pi electrons and these as being pi electrons. So 2, 4, 6. A total of 6 pi electrons, which is Huckel's number, delocalized throughout our ring, throughout our overlapping p orbitals. And so we can say that the thiophene molecule is aromatic. It satisfies both of the criteria for this. And